This is Algebra 2 with Trig, 8b.4d. We're going to evaluate inverse trigonometric functions. So the inverse trig functions allow us to find a value of theta. We're finding the angle, so that's why we're using inverse. And it corresponds to a given value. In order to obtain the unique angle, we have to restrict the domain of the original trig function. So let's talk about what this restricting is. It's all down here, what we'll be doing, but we'll discuss it a little bit right above it. So for sine, we know sine is a y value. So sine is a y value, and on our unit circle, y values are positive going up and negative going down. So we're trying to figure out which quadrants that we're going to be looking for answers for. And for every one of these, sine, cosine, and tangent, we're going to be using quadrant 1 because that is positive for all the trig functions. Now, below the x-axis, sine is negative because sine is a y value. So below the x-axis is negative y's. So when we are doing our calculations, we are only going to get answers in these two quadrants. We're going to get values up to 90 degrees and including 90 degrees. And we're going to get values down to negative 90 degrees. When you type this into your calculator, you are not going to get a 300 degree value from sine or sine inverse. You're going to get a negative value if it's in the fourth quadrant. So you have one positive, one negative, and that is for sine. When we're talking about cosine, we will also be in the first quadrant. So when we're looking for an angle that has a cosine of a half, has an x value of a half, we know that that would be right up here. And if we used our calculator, that would tell us that it is at 60 degrees for where cosine is a half. It's 60 degrees. Also realize that it's 60 degrees from the x-axis coming over here. That's where cosine is also a half, so it's a little confusing. But that's what these shaded regions do. They tell us where the answers are going to naturally be at. So 60 degrees is going to be the correct answer, not some value in the fourth quadrant, which also has a cosine of a half. When we talk about negative, that's going to be anywhere to the left of the y-axis, where x is negative. Well, we want to continue our calculations one quadrant into the next. So we're not going to jump down to the third quadrant. We're just going to come over here to the second quadrant. So notice that when we work with cosine, we're going to be getting answers that are up to 90 and actually continue all the way up to 180. So you can get obtuse answers when calculating with cosine. You cannot get an obtuse answer, what angle, it will never give you for greater than 90. When you ask for what is the angle where sine is a half right here at about 30 degrees, or exactly 30 degrees. There's another spot over here that it is also a half, where y is positive, it goes up a half. You're not going to get that 150 answer. You'll only get it in the shaded regions. So you only get the 30 degree answer. And then the last one is kind of weird. Tangent is positive, of course, in the first quadrant. So yes, we're going to use the first quadrant. So anytime we're working with an angle that is positive, it's going to be in the first quadrant. But the question is, what's going to happen when tangent is negative? Well, tangent is negative in the second and in the fourth quadrant. Both of those are one after the other. Both of those are adjacent to this first quadrant. But what's tricky here is that tangent actually does not exist on the y-axis. This coordinate here is 0, 1. And when you do tangent, on the y-axis, it is undefined because our coordinate is 0, 1. Way up here. So when you do y over x, that's 1 over 0. It's undefined right here. So we're not going to continue into the second quadrant. We're going to swing over here into this quadrant. Because remember, this is 1, 0, which would be y over x for tangent, which is 0 over 1. And that's just 0. So it exists all the way through until you get almost to the y-axis again. So long story short, when we work with tangent, we're going to get values almost up to 90 and to negative 90. You're not going to get answers that are obtuse. You're not going to get answers in the fourth quadrant that are in the 300s. These notes down here are explaining the exact same thing. They're telling us that sine, when you work with the inverse, you're going to be getting answers in this range, which are negative pi over 2 to pi over 2. That's usually in radians. Or negative 90 degrees to positive 90 degrees when we talk about degrees. Cosine is doing the same thing. And tangent is using the same thing, meaning going from 0 out to pi. I guess it's very much different, but 0 out to pi. But we've got a positive and a negative, just like we did here. But notice you don't get any negative answers with cosine, so there is some difference. Tangent is just like sine. It's going to be in the first and fourth quadrant, and we're going to get negative 90 to 90, negative pi over 2 to positive pi over 2. Sine of theta and tangent of theta, take a look, they would give us a negative possible angle, where cosine does not give us a negative possible angle. For cosine of theta, the negative value implies the second quadrant. We can get obtuse angles only when we work with cosine, and that'll come up later in mathematics, where we have to use cosine if we're trying to get an answer that's greater than 90. So, what we're being asked here is, what is the angle that has a sine of negative 1? Now, if you could look at your unit circle, that would be wonderful. Would rather have you be able to create your own image. You could either do it mentally, but I would love to see your picture. Where is sine negative 1? Where's the y value negative 1? Well, that's only going to be straight down. This coordinate is 0 for x, negative 1 for y. That's the only spot on the unit circle where the y value is negative 1. And that's going to be negative 90 degrees, and that's negative pi over 2 radian degrees. That would be the correct way to answer that. Not to call it 270, but to call it negative 90. You could use your calculator. We're not supposed to, but mathematically you can. Second sine of negative 1. Where is sine? What angle has a sine that's negative 1? And that's negative 90 degrees. It does not give you 270. Where is the x value? Where is cosine? Negative root 2 over 2. Well, I would hope that you know that root 2 over 2 means 45 degrees. So what you're visualizing at the moment is your unit circle. Root 2 over 2 means that you're going to be at one of these 45 degree markers. All the other ones, the 30 and the 60 from the x-axis, is always half in root 3 over 2. So negative, of course, is going to come this way. For a negative root 2 over 2, positive root 2 over 2. That would be your coordinate at this location. So what angle is that? What angle gives you that cosine of negative root 2 over 2? 135 degrees, or you could call it pi over 4 radian. Okay? It's not pi over 4, it's 3 pi over 4 radian. Because we're 1 step, 2 steps, 3 steps at 45 at a time. Or pi over 4, pi over 4, pi over 4. So it's 3 pi over 4 at that location. Tangents are often the trickiest ones to do. So in the past we've talked about how tangent will be root 3 over 3 for any of the 30 degree angles. If you actually remember that, then boom, you know exactly what the answer is. But otherwise, you have to calculate it. You have to kind of guess, is it going to happen at 30 or is it going to happen at 60? It's definitely not going to happen at 45 because 45 has x's and y's that are the same, so the tangent's 1. It's not going to be at 45. It has to be at the 30 or the 60. I'm telling you that it's going to be long, short. We know it has to be the first quadrant because tangent's supposed to be positive. And when we test this, the y value over the x value, we take a half times 2 over root 3, cross the 2's out, so we get 1 over root 3, and you know we need to rationalize that denominator. So we get root 3 over 3, and that's what it was asking. When did we get that? We got that at a 30 degree angle, otherwise known as pi over 6 radian. These are 3 questions on the bottom that you can pause the video for, work through those on your own, see how you do for each of these. So here we have the sine is a half. We know that we use these 2 coordinates or quadrants. Sine is a half, so sine is down a little bit. So that's going to be way over at negative 30 or negative pi over 6. Because this coordinate is negative 1/2. Well, negative root 3 over 2 for x. And the y value is down a little. Over a lot, down a little. Where is cosine a half? Where's the x value a half? Well, if this is 0 and this is 1 in terms of your x values, half is right in the middle. So we go straight up to figure out where that value is. So what angle created that? A 60-degree angle created that, or pi over 3. This is the coordinate, half for x, root 3 over 2 for y. And the x value is a half, and that's at 60 degrees. Tangent is -1. That's negative. We know that we use these two quadrants for tangent and sine, but tangent for this case. Negative would have to be coming this way. The only way to get a value of 1 when you're dividing is when we divide the same thing, and that has to be root 2 over 2 and root 2 over 2. So negative root 2 over 2 divided by positive root 2 over 2 is a value of -1. So that happens at negative 45 degrees and negative pi over 4. On the flip side, we're evaluating when working with sine and cosine. We know our answers have to be between -1 and +1, because the hypotenuse, opposite over hypotenuse, is always going to be less than 1. The hypotenuse is bigger, so the bottom of the fraction is bigger. But when you start to do the reciprocals, you're going to flip it over, and it's the hypotenuse side over the opposite and the hypotenuse over the adjacent. So those are going to be greater than 1. And tangent and cotangent, it all depends. And you could have a range that is from infinity. But here we're just still doing the same thing. So we draw our circle. We're looking where cosine is negative root 3 over 2. That's going to be a long way over and a short way up. So that angle is 150 degrees, or this is going by 30 degrees. So 30, 60, 90, 120, 150. That's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Sine being root 2. Well, if you think about that for a moment, root 2 is bigger than 1. So sine cannot be bigger than 1. And root 2 is bigger than 1, 1.4. Negative root 3. Well, we know that at the 30-degree angles, you get root 3 over 3. So at the 60-degree angles, you're going to just get root 3. So the tangent of root 3 is 60, but the tangent of negative root 3 would be down here at negative 60. So that's over a short way and down a long way. And if you want to test it out, you could test it. So the y value divided by the x value, which is the y value times the reciprocal. The 2's cross off and you get negative root 3. That's going to be negative 60, or negative pi over 3. Now, what if we are outside the unit circle? Meaning we're not on values that are specifically for the unit circle. We're at a sine of 0.4. We can still think about it like this. If this is 1, y is the sine, right? So we're going to go up and down. So if this is halfway in between, and that's straight across for the y value, we're supposed to be at 0.42. So we're going to be making an angle that's coming up here. And that's going to be sine inverse of 0.42, and that's going to be a 24.83. And for us to do it in radians, we would have to convert our calculator over to radians. And then do sine of 0.42 again. And the radian is going to be 0.43 tenths hundredths. So you want us to round to the nearest hundredths. But these are radians. Tangent, that's a little harder to represent with a circle. So we do tangent inverse of negative 1.7. I'm expecting to have a negative angle because it's negative. It's going to give us an answer down here in the fourth quadrant because tangent is first and fourth, but because it's negative, it'll be here in the fourth quadrant. So it gives us a negative radian. And if I switch this over to degrees, I get negative 59.53 degrees. So that would be coming in here like that. A cosine value, that is negative 0.8. Well, negative 0.5 would be here. Negative 0.75 would be halfway in between. So negative 0.8 is like way over here. And we come up. And that's the angle that we would be talking about. So it's going to be an angle way bigger than 90. I think it's going to be bigger than 150. So cosine inverse of negative 0.83 gives us, okay, so it was not bigger than 150. That's interesting. Okay, I guess that does make sense. Because 0.83 is going to be less than root 3 over 2. So yes, that would give us 150. Okay, just got to see if things make sense. And so that's the degree. Now if we switch it over to radian, alright, trying to retype it myself. Cosine inverse of negative 0.83 in radian. So we found both degrees and radian. Alright, so here we're talking about the cosine of 0.4. So 0.5 is here, so 0.4 is a little bit shorter, so that's coming up to here. So that has a cosine of 0.4. Well, that's not on the unit circle. We don't know that value. We know cosine that's going to be 0.5, but we don't know the cosine is going to be 0.4. So we do cosine inverse of 0.4. That gives us, that's the radian. We don't want radian, we want degrees. So that's a 66.42. 66.42. That's the angle that's being formed right there. Well, we don't want 66. We want the value that's going to be down here. Notice that if this is 0.4 for the x, that we've got to come straight down here and look at that angle, but we don't want it to be negative 66. That would be a possibility. We don't want that one either. We want it to be all the way around. We want a number bigger than 270. So that's actually going to be 360 minus the 66. Because this triangle and that triangle are identical. Congruent. So 360 minus the previous answer gives us 293.5 degrees. Now we can test this. We can test this by saying cosine of that angle. We want to put in the exact value. Put the A and S value in there. Don't put the rounded number in there because you want it to be exactly 0.4. Let's come on over here to tangent. Tangent of 2.1. Well, tangent of 2.1, we know we get a value of 1 when we're right in the middle. And we're going to get a value less than 1 if we're down here and greater than 1. Remember, tangent is y over x. So for the y to be bigger, we're going to get a value that's bigger. So we do tangent inverse of 2.1, and that gives us a 64.54 degree angle. We want the other angle that's also going to have a tangent of 2.1. Notice that 2.1 is positive. So what other quadrant has positive tangents? This is positive, positive. This is negative, positive, so that would give you a negative tangent. Negative, negative. That would give us a positive. All students take calculus. Take is tangent is positive. So we're going to extend the bar down here, and this is going to be our 64 degree angle. So that's 180 plus the 64 degree angle. 180 plus our previous answer is 244.54 degrees. Now we can test that theory by doing the tangent of that angle. The A and S is our previous answer, and that gives us exactly 2.1 like we were expecting. So we're looking for a sine. There would be a y value of negative 0.5. We want to be at negative 0.23. We come over here and we want this value. But remember, sine is not going to give us a value between 270 and 360. It's going to give us this negative answer. Round it up to get 0.30. So we have to do 360 minus that little bit. To be exact, we want to use this, 360 minus the previous answer. Don't use a rounded number. So the best answer is 373.297. which would really be 273.3. But when we test our answer and call it sine of this angle, we're going to get there it is, minus a negative. That's not what we're looking for, was it? We need to add the negative number. That was a trickery one. 360 plus our value from up here. We need a value less than 360. That was a little confusing. We needed a number less than 360. But because we were minusing, coming down, a negative answer, that actually meant plus for as far as the calculator knew. All right, last one. So we're looking for a cosine of 0.75, or 3/4. Well, that's a half, so 3/4 is about there. So we come straight up. So we want to know what angle that's going to be. So that's the cosine of 3 divided by 4. No, it's got to be cosine inverse. The answer just didn't make sense. 3 divided by 4. Cosine inverse of 3 over 4 is 41.41 degrees. So this is a 41 degree angle. Well, we want the other spot that we would be between 270 and 360. We're going to drop down that same amount. So this is going to be 360 minus 41.41. 360 minus our previous answer. And that is 318.59. And if we test it to the cosine of that angle, we get exactly 0.75, which is exactly the fraction 3/4. All right? You all can work on those. I'm signing off.